Okay, so we just left off with casting, and in this one, we're going to show how to fix that error when it gets invalid input into the casting function. A common time where this will happen is if you get user input and then they enter something that doesn't work and it breaks your code, and then you're left with a program that just doesn't function correctly and the user might be confused. So we're going to introduce some new control flow structures, and this is going to be a try and a catch block using the keywords try and catch. I'm sorry, not catch. I'm used to other programming languages. So typically in Java and other languages, they call it try catch, but in this one, it's try except. That's the syntax for Python, is try and except. And this value error, we'll get that in just a second actually. So this try is telling your code, attempt to do the next following lines of code. And so we'll put our int function in here, and we'll give it invalid input, which is the word 10. And if we try to run this without the try and except, I'll go ahead and save this, jump back over here, do that one. It gives me the value error like we had in the last program. And so to handle this, where it doesn't break the code but does something else instead, wrong one, I'll say try casting 10 to an int, and I'll put except, which is the exception. I'll put value error, and I'm getting this value error, I'm getting it from right here. This is the type of error. And so we're saying if you get this type of error after running this code, do this instead. And so right now we're taking in 10 as a word, so we might say int, put 10 right there as the number in the string data type. And if we put this into a variable, I'll just declare a variable, I'll call it value, set equal to 0. So let's say we try to update value here. And on line 6 we do the same thing, which this code is saying try to store the number 10 into value. And if it doesn't work on this int conversion function, then do it this way instead. And we'll print out our value down here to see what happened. We'll run it again, and we get 10. And so we've handled our error because we add this little thing that says, if it fails with this specific type of error, do this, and this code doesn't fail. Then it prints out our value. There's some more terminology that goes along with try and except. We also have else. And else is to say, if try works and there's no error in here, so if we put positive 10 here, that's not going to trigger this branch here because we didn't get that error. Then so it says, hey, my try worked, do this else instead of all of my excepts, because you can put different excepts down here. You can put different errors. You can have a whole chain of them if you needed to do that. And this else here is saying, if I had no exceptions, then print, we'll just say it worked first try. Jump over here, run it. There we go. Let me do this. It says it worked first try because this try didn't throw an exception. Let's make it throw an exception now. Put 10 in there. We should still get our value printed out, but we should not get this message because we threw an exception. And there we go. It didn't work first try, so it did not print that message out. And there's one other thing, and that is finally, And that's another thing you could put on here. I'll just print hi. We'll see what happens here. Yep. And so finally can be thought of as like something that happens regardless of what my try and except is doing. Yep. We have these 4 keywords for this try catch block. I'm going to review each one. Try says attempt this line of code or the following lines of code inside the try. Except says if you get this specific kind of exception or error in your code, instead of crashing the code, do this instead. And else says if I got no exceptions, print out or do these lines of code here. And then finally it says after all of that, do this regardless of what happened up here. And that is your try and except blocks in a nutshell. I'm going to show you a very practical way of doing this, or a very practical reason for doing it. And that is to get user input and try to convert that input into a data type. Let's say that we wrote a program and we want to get a number. Maybe we're running a program that prints out a sequence of even numbers. And we want it to run not an amount of times that we choose as programmers, but we want to run it an amount of times the user chooses. So I'm going to write some code to get a number from a user, and we want to handle it in case they didn't type in a number, in case they typed in a word or some alphabet character that just doesn't work in our code. So I'm going to say here user input equals the input function to get the user input. And I'm going to go ahead and print out a prompt for that user, and I'll say enter a number, please. And then we're going to try to convert that number into, or convert that input into a number. So we have user input here on line 2. I'm going to declare another one. I'm going to call it user input number. Initialize it to 0, so it already exists. Then we're going to update it to whatever our user put in. So we're going to make an integer. We'll say user input. And here, user input number. This might be a little confusing, the naming conventions I've chosen here, but just think user input is a string data type. That's what the input function gives us. And user input number is not a string, it's an integer. And so that's why we're using the int function to convert the string into an integer and store it into user input number. Okay, and I'll go ahead and comment out this line here. Actually delete it, we don't need it. And I'll put my except in here. It's already there. And then if they enter something incorrect, I'm going to go ahead and print out an error message to the user to let them know they did something wrong. I'll say error incorrect value, say incorrect input rather. And then after we say incorrect input, we'll say enter a number only. Let them know you put something that wasn't a number and it didn't work. Okay, so now come down here, we'll print out our user input number. We'll go and run this and see what happens. Enter a number, please. I'll say 7. And then we get another 7 printed here. Printed here because line 10 prints out that same number again. So let's clear this out, run it again. Enter a number, please. I'm going to say 7 as a word here. So I'll say SEVN or VEN. It says error, incorrect input, enter a number only, and then it prints out 0. So our code didn't break, it didn't crash, but we also didn't get the input that we wanted from the user. So to make this happen so that we get the input that we want, we can actually stick the user into an infinite loop until they enter something that we actually want. So to do that, I'm going to use my loop, a while loop, make it an infinite loop, and then that's going to run this try and except here. That's going to run this try and except here an infinite amount of times until we get the right input. So we try this to convert it. We get the value error, so we print out the error message. And now we want to get a new user input. Use the input function. We're asking to try again here. And then after this happens, we should let the loop try this line of code again to see if it works. And so this is going to be trying to convert to an integer. If it fails, we tell the user they put the wrong input in. We try to get input again from the user that's correct, and it just keeps doing this over and over again. And then we have to put one more thing in this loop, because as it is now, this will just keep looping forever. So to get this to break out of the loop, we're going to use our else, which is to say, if this line of code worked, we got a number that we can use, stop the loop. And the keyword to stop the loop, if we remember, is the break keyword. Okay, so let's run this now. Enter a number, please. I'm going to say the word 10. This is incorrect input, enter a number only. I'll say dogs. I won't listen to the prompt. And I can just keep putting stuff in here and it won't work. But if I give it a number, if I say 40, the program accepted the number. It went to the outside of the loop because it hit the break statement, because this did not throw an error. Remember, else happens when try, the code in try works properly. And so it reached the break statement which said, the current loop I'm in right now, the closest loop or the inner loop that I'm in, break out of that one. And so there's no other loop outside of this loop. Therefore, it goes on to line 14, nothing's there. Goes to line 15, prints out our number, and that's the end of our code. And so that is the last thing that happens. We get our number back to us. And to make this a little better, we might say, you entered, we'll say, and I'm going to put str here to cast this back to a string, funnily enough. And we'll concatenate it with the plus sign. And then we'll say, as your number. And I'm really bad at spelling, apparently. Oops. I'll put a space here to make this correct. Run it again, enter a number, random input, but I put 40 in there, it says you entered 40 as your number. Okay, and that's how you can get user input and make sure it's the correct input, or else keep asking them to enter something in until they get it right. It's with this combination of a while loop and a try, except, else block here, just like this. So I'll leave this here for a second. If you want to pause the video and study it some more, and you can take this code and put it into any program really, whenever you need to get user input of a specific type. It doesn't have to be an int, it could be a string or a float. We could replace this int with float, and they could use floating point numbers. But let's go ahead and try this code out real quick if I use a float. Just had that idea. Let's go up here, hit that. Let's enter 12.5. And that's incorrect input. And it's doing that because it's trying to cast a string, which is 12.5, into an int, but it just can't do that. It can't make that jump, and it can't make that jump because this period right here, the decimal point, is not a number. And so to make this work properly, we have to cast it to a float first, and then from a float, casts it to an integer. This is how you make the code work for floating point numbers and not integers. So we'll go ahead and stop this code, run it again, enter a number please, do 12.5, and it says you entered 12 as your number. Notice it didn't round it up because when it was converted into an integer, it truncated off the 0.5. And this is how you get a floating point number. And after all this, we could put a finally down here. We could say finally. We could print out, thank you for your patience. Because maybe this user was putting in incorrect input and couldn't figure it out for some reason. Just to put this finally in here, let's run this again. Say 12.5. That one worked. We'll run it again. We'll put incorrect input. We'll put 5 in there. It says, thank you for your patience. You entered 5 as your number. And this is our section on try, except blocks. And don't forget, there's also else and finally in there. But for now, that's it, and I'll catch you in the next one.